Okay, here we are. We got a video on fuel injector circuit resistance. This is a schematic in front of you. This is the 2004 Honda Accord, 4-cylinder, 2.4 liter. And in front of you is a schematic of the injectors and the relay feeding them and the PCM. We have the 8-channel scope hooked. We're on 6 channels on this car. As you look at your schematic, which you should print out, you want to take a print of this, a snapshot of it, and put it on your cell phone, put it on another computer, in some way that you can look at this schematic as you watch the rest of this video. So freeze the video as you're watching it, and then I'll see you in about 5 minutes. Okay, I'm back. Let's talk about what we're hooked into. Channel A, blue, is at the feed side of the injector before the connector, going down toward injector 4. Channel B, red, is at the injector itself, at the feed wire. Channel green, the 3rd channel, is at the injector at the control side of the injector, and channel D, yellow, is at the PCM at the control side. Channel 5, purple, is a low amp clamp at a junction box. That is down there, and that is going to be current ramping all the injectors. Channel 6, gray, is a fuel pressure transducer right here. And I got it from eBay, 9-volt battery, 5-volt regulator, which is on the fuel rail. So let me explain a little bit about this car. It does not have a fuel pressure test port, so I was able to use this piece. I got this from Honda for $26, and then I went online to a company called SUR&R, and they sell fuel pressure testing adapters and kits, where I was able to splice in a Schrader valve, and that's where I'm able to test the fuel pressure on this, right over here. So let's look at the scope now and begin to get this set up. Okay, we're on the scope. We can see what's going on, and let's start the car, and we'll see what. First, we'll start the scope and start to see what. How you doing? Hi, hey man. How's it going? Nice to see you. Nice to see you. I'll talk to you later. Thank you. Okay. As we can see, we're rolling across the scope. It looks like we'll freeze it and talk about the signals that we're looking at. So let me shut the car off. And as we can see, look at your schematic and look at the blue channel. We're strong. That's charging voltage, about 14 volts. The red channel is also going to be charging voltage, about 14 volts. The green and the yellow is the control side of the injector, and we'll look at that. That's this right here. Okay, that's a good-looking injector pattern. It's got the flyback voltage that kicks up. Below it is the current flowing through the injector when the PCM commands the injector open for a certain amount of time. In this case, we're looking about, I'm going to say, it looks like about 3 milliseconds we're open for. Okay, also let's look at the pressure drop. As we can see right here, we got pressure drops, which is equal because each cylinder is flowing about the same amount of fuel. On the gray, we got injector 4 firing order being 1342, so we 1342, 134. So we got equal pressure drops across the waveform. So let's start it up, and we'll get it back and take a look at your illustration. And what we're going to do is we're going to insert some resistance into the top connector on the top part of injector 4 on your schematic. You can see that little connector, that black male-female black connector. We're going to get the green crusties in and see the way they affect an injector. So let me start the car. And looks like we're flowing. You can see we're hitting on all 4 cylinders. fuel is flowing equally. And let's see what happens when resistance gets into that connector on the top of injector 4. You can hear the engine lope a bit, and we definitely have a waveform, and we're going to stop the scope and we'll analyze it. Okay, take a look at your schematic, and let's see what's happening here. Okay, we got to see now our blue trace is about the same. That really wasn't affected because that's before the resistance, as you can look at your schematic. Our red trace is affected because that's after the resistance. So the voltage drop available at the injector is about, let's see how much voltage is available at the injector. Okay, that would be about 6.65 volts, which is definitely not enough. So we can see the way the resistance has affected this. Let's see the current. Obviously, right, look at a fire cycle. Okay, right here, we're definitely flowing less current because of the resistance. And just think about Ohm's law, you know, where current, which is I equals E over R, our voltage being the same, and we add more resistance, we're going to have less current flow. So it's pretty obvious here in the waveform that the amount of current flowing into that injector is about 600 milliamps. A good injector is flowing about 1.3 amps. And also one more thing to note is, let's look at our pressure wave, how that's affected. You can see that. Let me stretch that a bit, and we can see that. Look at our pressure wave on gray. That is sticking out like a sore thumb. You can see when the injector flowed less current, we got less pressure drop. So right there on gray, we got less, and then the next 3 cylinders are good, and then the bad one due to the resistance. So anyway, looking back at your schematic now, we're going to do something to the circuit. We're going to insert resistance on the downside of the injector and see the way that affects it. So you take a look at the fuel injector, and between the fuel injector and the PCM is that connector, and we're going to insert resistance in that connector and see the way it affects the injector. Let me start the scope, get it back to here, and I'll start the car, and we'll take a look at what we got. Okay, looks like we're running on all 4 cylinders. Our current ramps are even, our pressure waves are even. Let's look what happens when resistance gets into that injector. You can hear the engine labor, and our patterns have changed. We'll take a screenshot, and I'll freeze the scope, and we'll analyze it. Okay. Okay, definitely affects it. We can see we got, let's take one channel at a time. Our blue channel is unaffected. Not too much, because this time our resistance is on the ground side. Red channel unaffected. The green channel looks severely affected, and we'll discuss why. And if you look at your schematic, look where the resistance is, and look where the green channel is. The green channel is on the what we'd call the intended load. That would be injector 4. Is on the ground side of the load. So basically, the green channel is checking the is checking voltage drop on the ground side, which in this case, due to the resistance, is excessive. So let's look at how much that is on the scope. we have a voltage drop. Let's see that. We got about almost 7 volts of drop there, which is way too much. And of course, we can see we have low current compared to the good one, which definitely will affect the way the injector performs. It just doesn't build up the strong enough magnetic field to get the fuel into the cylinder due to lack of amperage. So we also see it evident on the fuel pressure pulls, where the gray pull is less, and then the next cylinders, the gray pulls are normal. So pretty obvious right there. So let's get the circuit back to normal and talk about something else. We got some bonus material for you, and let's see how it goes. Let's get the thing running, get the scope on, and get this show on the road. Okay, we're back to normal. We got a scope screen. Looks like we're hitting on all cylinders. And if you take a look at the schematic, take a look at the word bonus under fuel injector and follow that line to a spot on the circuit. That spot is a very occasionally compromised solder joint. So when I tickle that, we're going to see the effect it has on this circuit. And we'll look at each channel. Nothing has changed as far as where we put the test leads. They're going to remain the same from when we started this whole demonstration. So let's see what happens when that section. Okay, definitely something happened there. Okay, so right at that spot on the schematic where the circuit opened up, we saw some action. And we saw it right here. We can definitely see what's happening at that circuit. When the circuit opens up, the blue, the red, the yellow, and the green all go down. From the spot from where the test leads are, you can see that that's very understandable because the voltage is going away from all those 4 spots on the circuit, and hence the injector is not going to flow current. As you can see, there's very little here as far as that. As far as our fuel drop, we can definitely see less fuel drop. It's very obvious right there compared to the next cylinder where we have a normal fuel drop. So let's look at another spot in the circuit where it may be even more pronounced or less pronounced. Now we can see a clear misfire. Okay, we know that the injector is completely not firing any fuel. We can see a radical swing on the fuel pressure, and we see low voltage on blue, red, green, and yellow, and we see a totally absent current ramp. So that would explain the misfire. This would be a really hard problem to catch if we did not have a scope. You could never get this with a scan tool. You would never get this on a DVOM, a voltmeter. So let's take a look, and we're going to add a little bit to the capture, and I will explain what's going to go on here. Looks like we're back running on all cylinders. I'm going to open up the 8th channel, and I'll explain what that is. We're going to go to 10 volts. And what we have now, we have a reference point. And I'll show you what that is. That's ignition, that's cylinder 1. And that is cylinder 1. And between this is a fire cycle. That's 2 crankshaft revolutions, 720 degrees of crank rotation. So this is a good looking capture here. We're hitting on all 4 cylinders. The waveforms, the voltage looks good, the current looks good. I'm going to add something a final channel to this demonstration to kind of prove a point, to kind of help us in a situation when we're trying to determine what cylinder is misfiring. Right here is a, let me show you. Hang on. Right here is what we call a delta sensor. This is a piezoelectric device I'm going to put in the tailpipe. You can see the banana to BNC adapter. I'm going to put this in the tailpipe, and I'm going to explain what it's all about. Put that in the tailpipe, and I'm going to turn on the channel. That would be the 7th or orange channel. And let's get that to about 5 volts. And we're going to see what that is. And I'll explain that transducer in a second. Okay, on the orange channel, we see a pressure wave, which is coming from the tailpipe. And what we see are, every time a cylinder fires, I'll stop the scope and explain it. Every time a cylinder fires, when the cylinder's on its way toward bottom dead center on its power stroke, its exhaust valve opens and it shoots a pressure wave down, out the exhaust valve, through the exhaust manifold, down to the tailpipe, where that pressure transducer in the tailpipe will pick it up. As if you can see, we're anomaly free. Everything is the same right here. So basically, I'm going to go back to our bonus material, and we're going to see, come on, come on, come on, come on. All right. Come on, a little technical difficulty here. Still with me? No. Come on. Okay. Looks like we had a little difficulty there. Been giving some trouble with this monitor. Okay, remember our bonus situation. Now we're going to go, and remember when we had that intermittent misfire where we lost voltage at injector 4. Now I'm going to do that same thing again. Take a look at your schematic and look at that spot. Let's see what happens here. Okay, let me freeze the scope, and I'll explain that. See what's happening. All right. Right here, we can see that it misfired. Obviously, our voltage went away. Our fuel pressure dropped. We had no current ramp. Injector did not fire. But I want to really concentrate on the orange signal and the burgundy signal. So I'm going to put these guys out of the way. That would be okay, we're just looking at orange and burgundy. Okay? And I'm going to set up something to look at 720 degrees of crank rotation. No, okay, no. Okay. That is, oh boy, come on. We're almost there, brother. You can get us. Okay, basically, that's the number one cylinder firing. That's pretty much top dead center for 1. This is bottom dead center for 1. Right about here, the exhaust valve for 1 opens, and it sends a pressure wave down to that transducer in the tailpipe. That's the pressure wave right here for cylinder 1. So I'm going to count the firing order from here, and we're going to see something. We got 1, 3, 4, 2. That's our smoking gun. All along during this demonstration, 4 has been the misfiring cylinder. So right there, we can determine that 4 is the misfiring cylinder. I just wanted to add that to the demonstration to show there are a lot of ways to detect misfires. And in this case, we can definitely see the effect of resistance and also a glitch in the wiring causing a misfire. So anyway, I'm going to bring this to an end. I hope you enjoyed it. There'll be more to come. And anyway, just keep in mind that a scope is powerful, and these problems, there is no other way you would have found these things without a scope. Thank you very much.